Good morning, everyone. Myself Ashish Verma, and this is our internal test one, part third or part C. So the question is discuss accuracy, completeness, and consistency issues proposed to or more quality dimensions relevant to legal analytics. Accuracy issues arise when complaints contains mistyped values or incorrect facts, which distort extracted features. Completeness problems occur when key fields such as timestamps, witness details, or incident descriptions are missing. Consistency issues appear when structure fields and narrative text contradict each other. Two additional quality dimensions important for legal analytics are timeless now and provenance. Traceability of who created or modified the information. So D equals to 1 minus F upon L F11 upon F11 plus F10 plus F01. Now for handling missing values and extracted features, discuss approaches, ignore tuples, manual completion, constant fields, mean, median, mean. So this is a question and this is our solution, which tells us that missing values, the extracted complaint features can be handled in several ways. One option is to ignore or drop tuples, though this may reduce data size and bias results. Manual completion uses expert review to fill gaps but is slow and costly. Constant fields such as zero or unknown preserve dataset size but may distort distribution. Mean, median, or mode imputation replaces missing numeric or categorical values with central tendencies, giving simple and consistent replacements but potentially reducing variability. Class specific imputation improves accuracy by computing these statistics within each complaint category. More advanced methods estimate the most probable values using probabilistic models or machine learning predictions, producing more realistic imputations when relationships among features are strong. These are our smooth extracted scores here. 13, 15, 16 mean is 14.6. For 16, 19, 20, our mean is 18.3. For 20, 21, 22, mean is 21, 20, 40, 42, 53, 21 सही है 53 63 sorry and so on for each group of three. Suggest ways to detect outliers, rare, very high impact with low evidence. Discuss other smoothing effects. So this means loose. Explain normalization methods for feature scaling. For minimum maximum scaling, maximum scaling transforms each feature to a fixed range, usually 0 to 1. By subtracting the minimal value and dividing by feature range, it preserves the shape of distribution but is sensitive to outliers which can stretch the scale. Z-score normalization. Z-score normalization rescales a feature so that it has means 0 and standard deviation 1. Each value is replaced by its deviation from the mean divided by the standard deviation. This method is effective when data follows a roughly normal distribution and is less affected by feature range differences. Z-score mean absolute deviation. Instead of standard deviation, this method divides the deviation from the mean by the mean absolute deviation. It is more robust because MAD is less influenced by extreme values, making it suitable for noisy or heavy-tailed complaint features. Decimal scaling. Decimal scaling normalizes values by shifting the decimal point a fixed number of places so that the largest absolute value becomes less than 1. It is simple and fast but less precise than statistical methods because it does not account for data distribution. For binding a case severity scores of 5, 10, 11, 13, 15, 35, 50, 55, 72, 92, 20, 215 for the equal frequency beans. Bin 1, 5, 10, 11, 13. Bin 2, 15, 35, 50, 55. Bin 3, 72, 92, 204, 215. Equal width bins range 215 minus 5, 210. If we create 3 equal width bins with 210 divided by 3 is equals to 70. So now our clustering based bins. Example k-means. K-means groups values by similarity rather than equal count or equal range with k is equals to 3. Severity values naturally cluster around low, mid, and very high levels. Approximate cluster based means low severity cluster 5, 10, 11, 13, 15. Mid severity cluster 35, 50, 55, 72, 92. High severity cluster 204215. Feature selection for section mapping. Summarize with a flowchart the techniques for choosing attributes used by the DSS. Forward selection. Begin with no attributes and one feature at a time. The one that improves section prediction accuracy the most until no further improvement occurs. Useful when many features are irrelevant. Backward selection. Start with all extracted attributes. Remove the least useful features step by step, keeping only those whose removal decreases accuracy, based when dataset is small enough to train many models. Hybrid method combines forward and backward steps. A feature may be added if it improves accuracy or removed later if it no longer contributes. More flexible and avoids local optima. Thank you for listening at the till end.